Hi all, welcome to Engineers Think Box. This is Sharu. So in this video we will be seeing on how to solve a problem on 8-point DFT using DIT-FFT algorithm, which is also familiarly known as butterfly method. So the question here is determine 8-point DFT of the given sequence x of n using DIT-FFT algorithm. DFT is nothing but the process of converting from time domain, that is x of n, to the frequency domain x of k. Here DIT-FFT is decimation in time fast Fourier transform. Before getting into this algorithm, you will have to concentrate on these two factors, that is nothing but twiddle factor calculation and order of input sequence and output sequence. So firstly, twiddle factor calculation. Since it is the 8-point DFT, we all know the value of capital N is equal to 8, that is the total number of values in the sequence. So when n is equal to 8, you will have to calculate 4 twiddle factors, that is half of n. That is nothing but n is equal, that is nothing but 8 by 2 is 4. So you are going to calculate 4 twiddle factors here. So the formula for calculating twiddle factor is W capital N power k is equal to e power minus j 2 pi k by capital N. Here I am going to calculate 4 twiddle factors as I said earlier by substituting the values of k as 0, 1, 2 and 3. So when k is equal to 0, you could see here I am going to substitute the value of capital N, that is 8, and here I am going to substitute the value of 0, which is equal to e power minus j 2 pi by 8 into 0. Anything multiplied by 0 will be 0 and anything raised to the power of 0 is 1. So the first twiddle factor value is 1. Next I am going to substitute the value k, k value as 1 here. So here it will be like W 8 power 1, that is n power k, which is equal to e power minus j 2 pi 8 into 1. Here I am going to cancel these terms. It will be like pi by 4 now. So now I am going to substitute, I am going to use this trigonometric identity, that is e power minus j theta is equal to cos theta minus j sin theta. Now this is in the form of e power minus j theta. The value of theta here is pi by 4. I am going to apply this trigonometric identity. So we will ultimately end up like cos pi by 4 minus j sin pi by 4. If you are going to calculate the values in the calculator, by keeping your calculator in the radian mode, which is most important, it will be like cos pi by 4 is 0.707 and sin pi by 4 is also 0.707. So this will be your next twiddle factor. Next, we are going to calculate when the twiddle factor value when k is equal to 2. W 8 power 2 is equal to e power minus j 2 pi 8 into 2 in the place of k. Now I am going to cancel the values here. So it will be like 2 1s are 2, 2 4s are 8 and 2 1s are 2 2s are. So pi by 2. So e power j pi by 2 will be here. Now I am going to substitute this trigonometric identity here. The theta will be nothing but pi by 2. So the equation will be like cos pi by 2 minus j sin pi by 2. The value of cos pi by 2 is 0. The value of sin pi by 2 is 1. So when you simplify, you will end up like W 8 power 2 value is nothing but minus j. Finally, I am going to substitute the values of value for when k is equal to 3 and calculate the twiddle factor. W 8 power 3 is equal to e power minus j 2 pi by 8 into 3 in the place of k. So it will be like when I cancel this, it will 2 1s are 2 4s are. So 3 pi by 4 e power minus j 3 pi by 4 will be the answer. So finally I am going to substitute the trigonometric identity here. The value of theta is 3 pi by 4. So it will be like cos 3 pi by 4 minus j sin 3 pi by 4. Keep your calculator in radian mode. and if you are going to calculate, it will be like cos 3 pi by 4 value is minus 0.707, sin 3 pi by 4 value is 0.707. So my advice will be like, instead of calculating twiddle factor for each problem, this is how the twiddle factor is calculated actually, but instead of calculating twiddle factor for each problem, I would suggest you to remember these 4 twiddle factors when it comes to n is equal to 8, because when you are going to make a mistake in calculating twiddle factor, the entire problem will go wrong. So these 4 twiddle factor values, I'll advise you to remember it. So coming to the order of input and output sequence, in DIT-FFT algorithm, that is in decimation in time fast Fourier transform algorithm, the output sequence x of k will be in natural order and the input sequences will be in bit reversal order. So for this, if you get into the problem, you will understand this. That is, you could see here, these are the input and these are the outputs. Okay, so here the outputs will be in the natural order, that is 0, 1, 2, 3, 4, 5, 6 and 7, but input will be in bit reversal order. That is, what is this bit reversal order is, you will be writing from 0 to 7. The binary values we all know, 0, 0, 0, 0, 0, 1, 0, 1, 0. So you will be writing the binary values. Now what you will be doing is, you will be reversing each of the binary values. So 0, 0, 0, 0 will be 0, 0, 0. This will be like 1, 0, 0, 0. That is, from this side to this side you are going to write. So again, this will be like 0, 1, 0. This will be like 1, 1, 0, 0, 0, 1, 1, 0, 1, 0, 1, 1 and 1, 1, 1. Now after reversing, you will be converting this binary to the index value again. So it will be like 0, 0, 0 is nothing but 0. This is 4. This is 2 and this is 6. This is 1. This is 5. This is normal binary to a decimal conversion. This is 3 and this is 7. So this order is nothing but bit reversal order. From the index term you are converting to binary term. This we will be using for all the problems right from the engineering basics. This binary term is reversed, and this reversed binary term is now converted to bit reversed index, that is decimal form. We will be using this order for the input. So in this case you need not mug up these values. Just you can use your rough column, write the binary values, reverse the binary values, and you can reverse the, after that you can convert to the index values. So if you could see here, I have written in the same order: x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3, x of 7. So here the input in DIT-FFT algorithm, the input will be in bit reversal order and the output will be in the natural order. Now whenever this x of n is given, you will have to consider the values like this. That is, the first value will be x of 0, the second value will be x of 1 and so on up to x of 7. That is, the indexing will start from 0 here. So seeing this, you will be substituting the values for x of 0 to x of 7. So x of 0 value is 2, x of 4 value is 1 and x of 2 value is 2, x of 6 value is 1, x of 1 value is 2 here. So I am writing 2, x of 5 value is 1, next x of 3 is 2 and finally x of 7 is nothing but 1. So this is the first step in DIT-FFT algorithm. You will be drawing 8 lines. In one side you will be mentioning the input terms, and in other side, that is in time domain, in other side you will be mentioning the output terms. The input will be in bit reversal order, the output will be in the natural order. In the next step, we will be drawing the lines for DIT-FFT algorithm. This is the structure to be drawn. So here you could see it is divided into 3 columns. In the first column, the lines are drawn like from this point to this point and from this point to this point. In this column, this pattern is followed. In the second column, the line is drawn from this point to this point and this point to this point, here to here and here to here, and this pattern is followed in this column. In this column, the line is drawn from first line to fifth line, second line to sixth line, third line to seventh line, fourth line to eighth line, and similarly in this way. So this is the pattern followed in the third column. So after drawing this line, the next step is you will be inserting the twiddle factor, which we have calculated in the previous steps. So where you should insert this twiddle factor is before each line, that is before each of these columns, you will be inserting the twiddle factor for DIT-FFT algorithm. First, before this line, that is before first column, you will be inserting twiddle factors 0, 0, 0, 0. That is when k is equal to 0, we have calculated, right? That twiddle factors will be inserted here. In the next step, before the in the next column, before the lines, you are going to insert the next twiddle factors, that is nothing but 0 to 0, 2. And finally, before this lines, that is in the third column, you will be inserting twiddle factors when that is nothing but 0, when k is equal to 0, k is equal to 1, k is equal to 2, k is equal to 3. These are the steps to be followed for DIT-FFT algorithm. After writing the input sequence and output sequence, that is input sequence should be in bit reversal order, the output sequence should be in natural order, then you will be inserting this twiddle factor in this format. Initially 0, 0, 0, that is when k is equal to 0, we have calculated the twiddle factor, right? That factors will be placed here. Next, the 0, 2 twiddle factors, that is when k is equal to 0 and k is equal to 2, the twiddle factors are calculated, right? That twiddle factors will be placed before these lines, and finally these 4 twiddle factors will be placed before this column. K is equal to 0, k is equal to 1, k is equal to 2, and k is equal to 3. In the next step, we will be placing the multipliers. Multipliers are placed wherever the twiddle factors are placed. Okay, in the line wherever the twiddle factors are placed, you will be placing the multipliers. The value of multiplier is nothing but -1. Everywhere the value will be same in -1. So here in 4 places I have placed the twiddle factor. So in the 4 places I have placed the multipliers. Here in 2 and here 2. So here 2 places I have placed -1 and 2 places I have placed -1. And finally these 4 places I have placed -1. So the one more tip which I would give before getting into the problem is, wherever the values are placed consecutively, that is one after the other, you will be multiplying it. Now you just keep it in mind. When we are getting into the problem, you will be understanding how to deal with it. Okay. So now I repeat once again, the input sequence is in bit reversal order, the output sequence is in natural order. So 3 columns and the lines are drawn. Before each columns, the twiddle factors are placed. And finally, wherever the twiddle factors are placed in the same line, the multipliers are also placed. So this is the entire structure of the DIT-FFT algorithm before getting into the problem which you should be prepared with. Now I have substituted the values for input sequence. Now I am going to start solving the problem. First, this 2 will enter into this line and it will reach this point. Since there are no values here, it will reach the point as such. Now this 1 will enter into this line, and you could see one twiddle factor is placed here. Now, as I said earlier, whenever two terms are placed consecutively one after the other, you will have to multiply it. So 1 into 1 is nothing but 1. So this 1 will be reaching here after multiplying this twiddle factor. So now we have reached out like 2 and 1 here. In this point, you could see there are two lines connecting this point. That is, this point, this line is connecting this point, and this line is also connecting this point. So whichever this point is connected by these two lines. These two lines carry these two values, that is nothing but 2 and 1. I am going to add up these values. I'll ultimately end up with 3. In the next step, if you could see this point, this line is carrying this, this line is connecting this point, and this line is also connecting this point. Okay. So this line, you could see this line is carrying 2 here. That is this 2. This line is carrying 1, but you could see the multiplier is there here. Again, when two terms are placed consecutively, you will have to multiply it. That is 1 into minus 1 is nothing but minus 1. So 2 minus 1 is 1. So this is how you will have to calculate for the next thing also. So see here, listen carefully. This 2 will be entering into this line. Since no value is there, it will enter as such. This 2 will be carried forward as such. Next, this 1 will enter into this line. Since it is since the twiddle factor is there, it will be multiplied with this twiddle factor. That is nothing but 1 into 1 is equal to 1. So this 1 will come here. Now these 2 points are ready. Now we are going to consider the next point here. This point is connected by these two lines, that is this line and this line. This line carries 2. This line carries 2 and this line carries 1. So these two values are added here. So 2 plus 1 is equal to 3. Now consider this point. This point contains these two lines, that is this line and this line. This line carries 2, which will be coming as such, that is 2. This line carries 1, where the multiplier is placed. So two consecutive terms will be multiplied in DIT-FFT algorithm. So 1 into minus 1 is minus 1. So 2 minus 1 is 1. Similarly, this 2 will be entering this sequence here. This 1 will be entering this line. Since the twiddle factor is placed, it is multiplied here. So 1 into 1 is 1. So now in this point, this line and this line will be joining. So this line carries 2 and this line carries 1. So 2 plus 1 is equal to 3. And at last, this point will be carrying this line and this line. So 2 will be carried forwarded as such. 1 will be multiplied with this minus 1, and 2 minus 1 is equal to 1. So now this is the final step, which I hope it would be clear now. This 2 will be entering this line as such. This 1 will also be entering this line. Since here the twiddle factor is placed here, this 1 is multiplied with twiddle factor 1. 1 into 1 is 1 here. So this point is connected with these two lines. That is, this point is connected with these two lines, this line and this line. This line has the value of 2 plus this line has the value of 1. No no interferences here. So as such, it will be added. 2 plus 1 is equal to 3. In the next step, this line is considered. In this line connects these two lines, that is this line and this line. So this line carries 2 here and this line carries 1. Since there is multiplier here, I will be multiplying with this. 1 into minus 1 is minus 1. So 2 minus 1 is nothing but 1. Now we have completed these 2 points. Now I am going to the next point. So I hope this is clear now. Now I am going to the next point. Here the value is 3. I am checking if there are any interferences here. No interference. So this 3 will be carry forwarded as such into the next point. Next 1. 1 is also carry forwarded as such. Here this 3, here the twiddle factor is placed. So now what you should do, 2 consecutive terms are placed as such. Now you will be multiplying it. So 3 ones are 3. Next this 1 and this twiddle factor minus j is placed. 2 consecutive terms. So it will be like 1 into minus j is nothing but minus j. Similarly, this 3 will be carry forwarded as such. This 1 will be carry forwarded as such. Here twiddle factor is there. So 3 into 1 is 3. Here also twiddle factor is there, that is minus j. So 1 into minus j is minus j. Now this point is also completed. We will be moving for the next point. So in this point, if you see, this point has 2 lines connected to it. That is this line and this line. Look for this arrow mark here. You could see this arrow mark, right? So this line and this line is connected to this point here. This line carries value 3 and this line also carries value 3. So 3 plus 3 is equal to 6. In the next step, you will be considering this point. For this point, this line, for this point, 2 lines are connected. This line and this line. This line carries the value 1 and this line carries the value minus j. When both values are added, it will be like 1 minus j. Next, you will have to consider this point. In this point, this line is joined here and even this line is also joined here. You could see it follows a pattern, right? That is what you will have to notice here. Okay. So now if you could see this 3, it will not be coming here directly because multiplier is there. So when multiplier is first, this 3 will be coming as such, that is nothing but 3. Next, this 3 will not be carry forwarded as such since multiplier is there. So 3 into minus 1 will be nothing but minus 3. So 3 minus 3 is 0. So now in last step, this point, this point consists of this line and this line. So first initially this 1 will come as such, that is 1 here. Now if you could see, this minus j will not go as such here since multiplier is placed. So minus j into minus 1 is plus j. So 1 plus j. This is how these points are calculated. In the next step, that is, now we are going to calculate for these 4 points. Okay. Consider this point now. This point is connected by these 2 lines, this line and this line. This line carries 3, this line also carries 3. So 3 plus 3 is nothing but 6, which is equal to 6. Next this point. This point has this line and this line. So that is why the arrow marks are important when you are going to draw this column wise lines. Okay, these arrow marks are very important. So now this point consists of 1 here, so 1 will come as such, and this point consists minus j here, so 1 minus j will be the answer when you are going to add both. Now coming to this point, now it is clear, right? Okay, now coming to this point consists of this line and this line. The arrow marks are drawn like this. So here this 3 will come as such without any interference, no problem here. But here there is a multiplier here. So you will be multiplying these two terms. 3 into minus 1 is 3. So 3 minus 3 is 0. Finally, this point. This point is connected by these two lines. First this line and this line. So this line consists of 1 which will come directly. This j will not come here directly since multiplier is placed. Minus j minus 1, when you multiply this both, it will be like 1 plus, it will be like plus j. So 1 plus j is nothing but 1 plus j. So this is how this line is, these values are calculated. So now this first 4 points are completed. Now we will be moving on to this next 4 points. First point is connected by two lines. This line and this line. So this line consists of value 3. This 3 will come as such. This line also consists of value 3. This 3 will also come as such when I am going to add these both values. That is nothing but 6. Next I am going to consider this point, that is the second point. This point consists of this line and this line. Okay. Now this line consists of 1. This line consists of minus j. Since there are no interference, it will be carry forwarded as such. So when I am going to add these both 1 and minus j, it will be like 1 minus j. So now coming to this point, this line carries 3. So that 3 is placed here. This line also carries 3, but it is followed by the multiplier. So you are going to multiply this both. 3 into minus 1 is minus 3. So 3 minus 3 is 0. Finally, this point. This point consists of this line and this line. So initially this point consists of 1. This point consists of minus j, but it is followed by minus 1. So minus j into minus 1 is plus j. So we are going to add up both the terms, that is 1 plus j. So you will be ending up with 1 plus j. So now we have completed the first 4 points successfully. So after calculating this, I have to carry forward the values to this next point. Okay. Here this 6 will be carry forwarded as such since there is no interference here. This 1 minus j will also be carry forwarded as such. This 0 will also be coming here as such, and 1 plus j will also be coming here as such. But when you come here, this 6 will not go here as such since the multiplier is since the twiddle factor is there. I will have to multiply this both. 6 into 1 is 6. Similarly, this 1 minus j will not go here directly. Instead, it will be multiplied with this twiddle factor and it will end up here. Since these are complex terms, just keep it on hold. Okay. So consider this 1 minus j as x and this as twiddle factor as y. So here you will be ending up with the term xy, that is nothing but this 1 minus j and this. Okay. Now here it is 0, so anything multiplied with 0 will obviously be 0. Now it is 1 plus j here. If you are going to multiply this 1 plus j with this twiddle factor, again it is a complex number, so keep it on hold. I'll let you know what to do in the further steps. So this will be x, this will be y. So x multiplied by y is xy. So at this point it is xy. So now we have brought up all the points to this. And finally, we have come to the last section here. When you are going to solve this, first this point is consisting two lines. This is the first line and this line. Okay, so this line is carrying 6 here and this line is also carrying 6. So now I will add up both the 6's. 6 plus 6 is equal to 12. In the next step, you have to listen carefully. In this point, two lines are connected as usual. This is the first line and this is the second line. Okay. So the first line consists of the value 1 minus j. I will place it as it's 1 minus j plus this value is xy. Xy is nothing but 1 minus j into 0.707 minus j 0.707. That is what is mentioned here. 1 minus j 0.707. 1 minus j into 0.707 minus j 0.707. X into y. Now I am going to use calculator to solve this.
Now I am going to input this equation in this calculator. Before that, I am going to set this calculator in complex mode since we are dealing with imaginary numbers. For that, you will press the mode once. This represents the complex number, so you will be pressing 2. Now this calculator is set in complex mode. Now we can start inputting the values. First is open bracket 1 minus j. Since j is not available in this calculator, I am going to use I here. If you could see here, you can see I, right? ENG. So since if you just press ENG, I will be coming because it is in the complex mode. Close bracket plus open bracket 1 minus j again, 1 minus I instead of j, multiplied by open bracket 0.707 minus 0.707 I. Here one thing which you have to notice is this j should come after the numericals while we are inputting in the calculator. Otherwise the calculator will show syntax error. So please ensure that you are going to place this imaginary value j after the numerical value, that is like 0.707 I. Now if you press equal to, you will get the real value, that is 1. If you press shift and equal to, the imaginary value you will be getting, that is minus 2.414 j.
So in order to make the calculation simpler, that is here you have to multiply this both and you will be ending up with this one term, and again you will have to add up. Since these are complex numbers and the calculations are a bit complicated, I have made it as a single equation where you will have to use the calculator only once and you ultimately will end up with the right answer. So this step I will repeat again. This point is connected by these two lines, 1 minus j and this point xy. Xy is nothing but 1 minus j into 0.707 minus j 0.707. I am adding up these both values using the calculator. I'll end up with this answer. Next, if you are going to consider this point. This point is connected with these two lines. this line firstly and this line. Just nearly follow the arrow marks, that's all. Not a big deal. This 0 will come forward and this 0 will also come forward as such. So 0 plus 0 is nothing but 0 here. In the next step, you are coming to this point. This point consists of two lines. That is this point. That is this line and this line. The second line. Okay. So this line will be carrying 1 plus j. That is 1 plus j will be placed here as such. Plus this line is carrying x into y. X value is 1 plus j. That 1 plus j is placed here, multiplied by y value is minus 0.707 minus j 0.707. That is placed here. So if I use the calculator like I did for previous thing, I will be ending up with this. That is 1 minus j 0.414.
Next I am going to input this equation. Before that, set your calculator in complex mode. Now start giving your inputs. 1 plus I instead of j, close bracket, plus open brackets 1 plus I instead of j, close bracket, multiplied by open bracket minus 0.707 minus 0.707 I. The imaginary value will be coming after the numericals. Close bracket. If you press equal to, you will get the real value, that is 1. And if you press shift equal to, you will be getting the imaginary value, that is 0.414 j.
This point is connected with these two lines. This line and this line. Okay. Now you have this line is carrying 6 here. So that 6 will come as such. But here if you see, there is a multiplier hiding here. So you will have to multiply this both. 6 into minus 1 is minus 6. So this 6 and this minus 6 will get cancelled. So here the value will be 0. Now we are coming to the next point here. That is this point. So this point will be connected with these two lines. That is this line and this line. Okay. First, this 1 minus j. This line is consisting of 1 minus j. That will come as such. If you are going to see here, there is a multiplier here. So it will be like minus xy. So minus of, that is this 1 minus j, minus of x, that is 1 minus j. Again 1 minus j multiplied by y. 0.707 minus j 0.707. I hope this step is clear. I'll repeat once again. First, this 1 minus j will be placed as such here. Since there is a multiplier here, I am going to multiply this with this. So it will be like minus xy. So minus will be placed here. X is nothing but 1 minus j multiplied by 0.707 minus j 0.707. That is minus x into y. It is clear now, right? Now I am going to use calculator to solve this.
Now I am going to input this third equation in the calculator. Set the calculator in the complex mode. Open bracket 1 minus j, that is instead of j you will be putting I, close bracket, minus open bracket 1 minus I instead of j, close bracket, multiplied by 0.707 minus 0.707 I. and close bracket twice. If you plus equal to, you will be getting the real value, that is 1. If you press shift equal to, you will get the imaginary value plus 0.414 J.
In the next step, this point will be carrying this line and this line. Okay, so this line will have the value 0 and this line will also have the value 0. So 0 minus 0 is 0. So the last point now, this point has two lines, that is this line and this line. Okay, so now this line consists of 1 plus j. I have placed the 1 plus j as such. Here multiplier is there, so this xy will be multiplied with this multiplier and it will become as minus xy. So minus x value is 1 plus j, I have placed 1 plus j here, multiplied by y value is minus 0.707 minus j 0.707, that I have placed here, that is minus x into y. I repeat once again, this 1 plus j will come as such here, that is 1 plus j minus xy, minus x value is 1 plus j and y value is minus 0.707 minus j 0.707. Now I am going to use the calculator.
Finally, I am going to input this fourth equation in this calculator. So open bracket 1 plus I instead of j, close bracket, minus open brackets 1 plus I instead of j, close bracket, multiplied by minus 0.707 minus j 0.707, that is minus 0.707 I. Now close brackets twice. If you press equal to, you will get the real value, that is 1. If you press shift equal to, you will get the imaginary value plus 2.414 J. So this is how you have to use the calculator for solving these complex equations using imaginary numbers.
So after using the calculator, you will end up with this answer. So finally, this is the overall diagram. So the final answers which you will be considering is these things. Okay, this 12, this thing, this whole thing 0, this whole thing 0, this whole thing 0 and this whole thing. So this is the overall structure. All you have to do is you will be right from the input sequence, you will be carry forwarding the points to each and every section. Okay, if there is a multiplier in between, if there is a twiddle factor or multiplier in between, you will be multiplying the terms and you will be carry forwarding the points to the next consecutive points. Okay, so the things which you have to remember is the input sequence should be in bit reversal form, the output should be in natural form, that is 0 to 7 as such. This twiddle factor must be placed before the columns, before the these three columns without fail, and try to remember the twiddle factors, because if you are going to do mistake in the twiddle factor, you will ultimately end up with the wrong answers at the end. And I'll also give a tip to check how to check whether you have got the right answer or not. That is x of k, we all know we will be writing it in a set. Okay, 12 comma 1 minus j 2.414 comma 0 comma 1 minus j 0.414 comma 0 comma 1 plus j 0.414 comma 0 comma 1 plus j 2.414. That is all the values I am going to put it in a set, that is nothing but x of k. These are the values. Now if you are going to see the solution, x of 0 will be the sum of all the values in this set, that is in the question set. The question set is this. So if you are going to add this 2 plus 2 plus 2 plus 2 plus 2 plus 1 plus 1 plus 1 plus 1 plus 1, that is 12. And this x of 1 and x of 7 will be conjugates, minus j plus j. Then x of 2 and x of 0 will also be conjugates. Here it is 0, but if in case it consists of values, it will also be conjugates. Now x of 3 and x of 5 will also be conjugates, minus j plus j. X of 4 will be constant. So x of 0 will be sum of all the values given in the question. X of 1 and x of 7 will be conjugates, and x of 2, conjugates, okay. X of 2 and x of 6 will also be conjugates, and x of 3, x of 5 will also be conjugates, and finally x of 4 will be a constant. It's not necessary that it should be 0. It can be any constant values. Okay, so this is the overall method to solve 8-point DFT using DIT-FFT algorithm. If you have any doubts, post it in the comment section. I'll be replying for each and every comments. Thank you.